In today's lesson, I'm gonna be talking about logarithmic functions. So some of you guys might not know what a logarithmic function is, so I'm gonna explain right now. Um, I'm sure we all know what like an exponential function is. It's just like 2 to the power of 4 or something, or like 2 to the power of 2, which is equal to 4. Okay, someone joined. Okay, basically, this is an exponential function. So what if like we have, let's say we get an equation that's like with an unknown power, like 2 to the power of x equals 4. And we have an unknown variable here. So like, does anyone want to like try solving this question here? Just for fun. Does anyone have any idea on like how to find this missing variable here? No, okay. Basically this is what logarithmic functions are for. They are the inverse of an exponential function, and we write them as log base b of x. If you just input these variables, we get uh, log 2 of 4, which is equal to 2. So that like directly translates to here, where this variable would just be 2, which basically leads us to our definition here. Um, so essentially, the inverse of the exponential function is called the base b logarithm function. And this function is denoted as the inverse of f equals to the log base b of x. And the base of the logarithm b, as you can see right here, it should always be greater than 0, and it should never equal to 1, because like that just kind of ruins the point of the logarithm function. Um, so the base of the logarithm function can essentially be any number greater than 0 and not equal to 1. But there are two special bases that you guys should remember, that are used in logarithm functions. And these two bases both have um, special notations. So first, the first base that we're going to be talking about is the common um, logarithm, which is base 10. And it's usually just written as log x. Sometimes we just don't write the 10 because this is just a special notation of that. And the other base is called the natural logarithm, which is a real number, and it's written as log ex. And e is an infinite decimal, but we usually just round it to 2.71. So um, also the special notation for this is usually written as ln x instead of log ex. So okay, so we have this little example here of like just to reiterate what a logarithmic function is, here we have like um, here we have this equation that is f(x) equals 2 to the power of x. And when x is equal to 2, f2 equals 2 to the power of 2, which is 4. And basically the inverse of this function, as I said before, is going to be log 2x. And when x is equal to 4, f4 is equal to log 24, log base 2 of 4, which gives us 2. So as you can see, I'm going to explain like just down here, like how to alternate between these two forms. So, do you guys have like any questions about like the definition of a logarithmic function or like anything else? No questions? Okay. Um, next, next up, we're gonna be talking about alternating between these two forms of logarithmic and exponential form. So basically, um, in exponential form, we have the base and then we have the power and then we get the result. But for logarithmic functions, we have we first write the base and then we write the result, which we get the power. And like, yeah, okay. For example, like, oh, you can also ask like two students in this meeting, Amanda and Kevin, about this. Like, they also learned about these functions, and I think they'd also be able to answer your questions. So, anyways, moving on. We just have a little example here. For example, like 2 to the power of 3, which is 8. This is exponential form. So converting this to logarithmic form, we get log 2 of 8, which is equal to 3. So as you can see, the power here is moved here. So logarithmic functions are usually like you're finding the power. And yeah, basically that's um, what a logarithmic function is about. Okay, next up we have, okay, next up we're moving, oh wait, do you guys have any questions about like alternating between the two forms of these? Like, I don't know, like Amanda, do you have any questions about this? Or like Kevin, do you have like any questions about this? No. Okay, no questions? Okay. Okay, let's move on then. Okay, we're moving on to graphing now. Um, these are the properties of the logarithmic functions. So let's just suppose that f(x) equals to log bx, log base b of x. The domain of f is 0 to infinity, which means that like the x value can be anywhere between any like positive real number, essentially between 0 and positive infinity. And the range is negative infinity to positive infinity. So essentially the output of the x value can range from anywhere between like negative infinity and positive infinity. So like any questions? Like okay, I'm gonna actually ask you guys some questions because why not? So like um Amanda, like what is a domain? Like what does it mean? Amanda, are you like can you hear me? Like okay, I guess not. Okay. Let me just ask Kevin then. Kevin, what's a domain?
X value.
Cool. Okay. Okay, yeah. So I think you guys got that. Next up, um, okay. The points, um, 1 and 0, 1, 0 is on the graph of f, and x, when the x value is 0, that is the horizontal asymptote of the function. Essentially a horizontal asymptote. So as you can see, this is where x is equal to 0. This the y-axis right here. Essentially, an asymptote is like a limit of sorts. Like essentially, this function, this curve right here, is never going to touch x equal to 0. Like it's just gonna keep going on forever, and it's gonna keep getting closer and closer to x equals 0, but it's actually never gonna touch it, even though it looks like it's touching it here, but it's actually not. So yeah. And f is 1 to 1, continuous and smooth. 1 to 1 is essentially like for every x value that there is, there's always going to be an output value. There's only going to be one output value, by the way, which is why it says 1 to 1, because there's one x value and one output value. 2 to the power of 3 is 8. Okay, this is a 1 to 1 example here. Where there's only one x value and which gives this this one output value. This is 1 to 1 because there's only this one x value and this one output value. So yeah, and this is not 1 to 1 because as you can see, there's two output values that you can do to get this. So yeah, and continuous essentially means like there's no holes in the graph. Um, I don't know if you guys know about this, but like essentially, um, this is a hole in a graph. Like there's no derivative here. And the same with smooth, like the graph essentially when it says the f is smooth, it means that f is one smooth curve like this, and there's no like jagged line like that. And here there's also no derivative. And AI, like AI can't calculate any AI can't calculate when there's no derivative because they use a lot of derivative to like calculate stuff. So essentially they can't calculate using derivatives when there's like no derivative. So they often have to use like a lot of ways to like bypass this hole or this jagged line here. And there are a lot of ways to do that, but like I shouldn't get off topic. Okay, next is basically what we talked about before. Um, b to the power of a equals c if log base b of c is equal to a. This is just converting between the logarithmic and exponential forms like we talked about earlier. And okay, this next one is okay, log base b of b to the power of x is for all equals x for all x values, and um, b to the power of log b of base b of x is also equal to x for all x values greater than 0. So this essentially means like, let me just give an example. Log to the power of 3 is going to equal 3 because these essentially just cancel and we're just left with the 3. And it's also the same here for the other. Like the other one. 2 to the power of log base 2 of 8 is still equal to 8 because this just cancels out and we're only left with 8. So yeah, that's for any values of x that are greater than 0. Okay, now we're moving on to like the actual graphing part. Um, for example, okay, hold on. Anyways, for example, let's see log base 2. Let's just use the example log base 2 of x. Um, essentially, the graph of f is always going to be increasing infinitely, and as x approaches 0 from the right side, so this way, f is going to decrease down, as you can see. It's going to negative infinity, and as x approaches infinity this way, the graph of f is also going to go towards infinity, upwards, as you can see in the graph below. This is what the graph of f should resemble. Yeah. And for the next one, if if the base of b is greater than 0, but it's less than 1, for example, like log 1 over 2 x, f is always going to be decreasing, and as x approaches 0 from the right side, f is going upwards. It's approaching infinity, but as x approaches infinity from like this way, then f is decreasing and it is approaching negative infinity. And this is what the graph of f resembles. Okay. You guys have any questions about like the graphing part of the logarithmic functions or anything? No questions? Okay. Okay. Next, um, we're gonna talk about the inverse properties and the one-to-one properties. Actually, these are we already kind of talked about these because like the properties are literally just like e to the power of a equals c if like log base b c is equal to a, which is we already talked about it earlier, and the one-to-one properties are we also talked about this earlier. Yeah. You guys can like read this at home if you want. I'll send the link to this tutorial in the Discord server if you guys want to like just get some further insight on this on these properties. Okay. Um, okay, next we have the algebraic properties of the logarithmic functions. Okay, let's just let gx equal to log base b of x. Let's just let this be a logarithmic function where b is greater than 0 and b is not equal to 1. So these are some like really important rules that you guys should remember because you're going to be learning about this in high school, and like you're probably going to use these three rules a lot as well as in math contests. Um, okay, so let's first start off with the product rule. Um, so essentially, let me just use an example for this. Let's just say um, log is b of 2 um, of 8x. So by the product rule, we can separate these into two logs with a plus sign in the middle. So this would become log 2 8 plus log base 2 x. This is the product rule. Okay, next we have the quotient rule. This is pretty similar to the product rule. It's just you're subtracting instead of, it's just like the opposite of the product rule. Let me just use the same example. Um, log is 2. I'm just going to use 8 divided by x this time. So by the quotient rule, we can separate this into two logs with a minus sign in the middle. So this would become log base 2 8 minus log 2 of x. So yeah, this is the quotient rule. And for our last and final, for our last rule, we have the power rule. Let me just use the same example again. Log base 2 of, let's just say 2 to the power of 3. The power rule, essentially, we're going to move this power here. So we would get 3 log base 2 of 2. Yeah, like this. Okay. Does anyone have any questions about those three properties? No questions? Okay. Next we have the change of base formulas. So for this, let me zoom in on this just so you guys can see a little clearer. Um, yeah, this should be good. Okay, so essentially, a to the power of x is equal to b to the power of x log b of a for all real numbers of x. This is the exponential form. Since we're talking about logarithm functions, actually, I'll just go over both. But the logarithmic form is log a x is can be converted into log base b of x over log base b of a. Let me give you guys an example here. Okay. Let me just think of an example. Okay. Yeah. Okay. For this exponential change of base formula, let's just say we have to the power of 3. And let's just say like our b value is going to be 5. Yeah, okay. Yeah, okay. First we can just convert this as, let's just write it like this for now. 5, 2, 4, 3. Okay, as you guys can see, I haven't used the power rule yet to bring this 3 over here, but we can do that right now. And yeah, we get 5 power of 3 log, base of 5 of 2. So this is a converted exponential function. This is the converted formula where you change the base. Does anyone have any questions about that? Okay, then I'll just move on to the logarithm form. Okay, let's just use the same one. Okay, so let me log 2, 3. Okay, so here we have our logarithmic function before the change of base formula. So we can just convert this into log. Let's just say our b value is 3. 3 over log 3, 2. Okay, so this is what it would look like converted, and we can just simplify this. So as you can see, like we can just cancel this. No, wait, sorry. We can just say like 1. This is just equal to 1 because like you're basically just, it's just like 3 to the power of 1. So we get 1 here, and this we don't really have to simplify. And we can just write this as 1 over log base 3 of 2. So this is our converted form. So yeah, essentially like log a b is equal to 1 over log b a. Yay, we got a new formula. Do you guys have like any questions about this? Okay, I guess not. Okay. Obviously, you guys can also just look at the tutorial again. And if you guys have any new questions, like after the class, you can also ask me in the Discord server. Okay. So now we just have some examples, and I actually want you guys to do some exercises just for some practice to make sure you guys understand what I'm talking about. So I'm actually going to make you guys do this exercise here. And I'm going to give you like, let's say 3 or 4 minutes for this. Um, yeah, let's just say 4 minutes. And I will also send the tutorial. I will also send the tutorial link right now so you guys can do this. Okay, let me just stop sharing really quick. Okay, I'll give you guys like 3 minutes starting from now. Sup, Liliana. Okay, basically, we're just in the middle of like doing a question. We're just doing some exercises right now. Um, I'm sharing the screen of the exercise right now. So like, if you want to do it, you can try. But since you weren't here for like the earlier explanations and teaching, like you don't have to do it if you don't want to. But you can also just give it a try if you want.
Oh, okay.
All right, guys, it's been like uh 4 minutes, I think. So, does anyone have a solution for this exercise? Like, does anyone want to show what they did to solve it? Kevin, do you wanna do it?
Didn't finish yet.
Oh my God. Okay. Did anyone finish? I guess not. Okay. Um, okay, I guess I'll just explain them. Sorry, I'll just explain the solution now if nobody's finished. Okay. So essentially, okay, let's see what our equation is. Our equation here is log base 6 of 216 over x to the power of 3 of y to the power of 4. Wait, let me just move this upward so I have more space to write. Okay, so first step, we should use the power rule to move this 4 to the front here. So we just we'll get 4 log 6 over 216 x to the power of 3 y. We're just moving this 4 first because we want to get anything we want to get rid of anything outside of the bracket before we start working inside of the bracket. So now that we've gotten rid of that, um, we can start moving to um, this this part here. Okay, so I think our next step should be using the quotient rule because as you can see, this is a division thing. So we would get 4 log base 6, 216 minus 4 log 6 of x 3y. Okay, so now that we have separated um, the what's inside the bracket, we can start working from here to simplify. So next, wait, okay, there's still something we need to separate here. Okay, so next we're gonna separate this x to the power of 3 and y because it's a little hard to simplify like that. So next, I am going to use the product rule because this is multiplication. So we get 4 log 6 and 16, 4 log 6. I'm going to put this in parentheses for now. Um, whoops. X to the power of 3 plus 4 log base 6 of y. Okay, so now we've separated this into this. And the next thing I'm gonna do is I'm gonna start simplifying this thing here. And I'm also going to use the power rule again to just move this 3 here into this. So what we would get is 4 log base 6 of 6 to the power of 3 because 6 to the power of 3 is 216. And I guess I can remove the parentheses now, which would turn this into a minus sign because Like essentially just this minus sign here just turns this plus sign into a minus sign as well. So this becomes 12 because we're moving the 3 and there's already a 4 here. So we're just going to multiply the 2, which gives us 12 log 6 of x minus 4 log 6 of y. Oops. Okay. And now we can just further simplify. These are going to cancel and just become like 1. So our final answer should be 12 minus 12. Whoops. 12 log 6 of x minus 4 log 6 of y. And that should be our final answer. Do you guys have any questions about this? No questions? Okay. You guys can take a picture of the solution if you want, just so you can like redo this exercise at home. Okay, yeah. Okay. Let's move on. There's also a solution in the tutorial here, if you guys want to look at it. So we have another exercise here that I want you guys to do because I think this one is easier than the first one. So I'll give you guys another 4 minutes to do this, I guess. Yeah, I think 4 minutes is enough. Okay, 4 minutes starting now. I'll check back on you guys at 8:54. Okay, guys. I think it's been like 4 minutes. Um, has anyone solved this? Kevin, did you solve this one? Kevin, are you dead? Oh, he's okay. Uh, do you guys want more time or like do you just want to get the solution now? Okay. I'll just I think I can give you guys another 2 minutes. Okay, guys, it's been like 2 minutes, I think. So I guess I'll just start explaining the solution now. Kevin, did you like, guys, did you like finish this exercise? Like, does anyone want to try it? Did anyone finish or like, no? Okay, I guess no one. Okay. I'll just move on to the solution. Okay. Let me just. Okay. Okay, here we go. So, first, let me write down our equation. Okay, I need some space here. So, okay, here we go. So our equation is log base squared, square root of 2 of 4x to the power 3. Okay, this is our equation here. So first, I think, okay, first let's do the product rule to separate these two. So we would get log square root of 2, 4 plus log square root of 2 of x to the power 3. So this is, now that we have separated um, the 4 and the x to the power 3, next we have to do the power rule to get this 3 over here. So we would get log 2 4 to 3 log 2x. Okay, now I think we can start simplifying. So we would just get this would just become log square root of 2 to the power of 2, and these essentially just cancel. Wait, no, these the square root of 2 um 2. Okay, my bad. Hold up. Okay, so this just essentially, like, hold on. Okay, let me just write this as the square root of 2 to the power of 4 plus 3 log 2x. So with this, these two will just cancel out, and we're just left with the 4. So let me just write this as 4 plus 3 log the square root of 2 of x. So this is our final solution here. Does anyone have any questions? Okay. You guys can also view the solution here on like the tutorial. So, okay, like in most cases we would be done here, but like the like base of the square root of 2, this isn't exactly like a really commonly used base. So I kind of want to change it to a more common base, such as like 2. So we can do this by converting the base of the logarithmic function. So for now, I'm going to move our old solution to the side, and we're going to exclude the 4 for now, just so we can focus on the log function. Okay. So right now we have 3 log square root of 2 x. Wait, let me move this. Oops. Okay. And we talked about changing the base formula before. So that's what I'm going to do here. And this is going to become 3 log 2, which is our desired base. So I'm going to write it as 2 instead of x over 3, wait, no, of log 2 square root of 2. And from here, essentially, we can just start simplifying. And this can, so first, this can be, the square root of 2 can be written as 2 to the power of 1 over 2 in exponential form, I guess. So instead, let's just write this as 3 log square root of 2x over log 2 to 1 over 2. Okay, now that we've converted this, we can start simplifying. So these just cancel because it's just 1. So we're left with 1 over 2. Or we can just use the power. And we're also going to just use the power rule to bring this over here. So we get 3 log 2 of x over 1 over 2. And as you guys know, like when you just multiply by like a decimal that's less than 1, like no, when you divide by a decimal that's less than 1, essentially you're just multiplying. So um essentially this is just multiplied by 2, which we would get 6 log base 2 of x. And now we can finally bring the 4 back. So plus 4. And this would be our final solution. So does anyone have any questions about that exercise?
Hey, Buster,
What?
I got another way.
Annotate. Hold up, let me just clear my screen.
No, just for the changing the base.
I speak your answer. What we got?
You just do this one. Basically, you could just take the like exponent in the base and just reciprocate it and move it to the front.
Yeah, I mean, yeah, you
Like
could.
that. Especially for this one. Oops. You just
Yeah.
write square root of 2 as 2 to the 1 over 2, and then you move the 1 over 2 to the front, and you get a 2. There you go. It's a 6.
Yeah, you could. I mean, yeah, sigma.
I will say, but
Sigma solution.
I know,
Okay.
right? It's a lot. It carried me
Wow.
in advanced functions, bro.
Oh my God. All right, guys, you heard that. Basically, you're gonna learn a lot about this in advanced functions in high school if you take advanced functions, which I'm pretty sure all of you guys will. And um, we're also hosting AMC 10, so you're also gonna do a lot of logarithmic functions. We're hosting one in November actually, so like if you guys want to join, like just DM, just like say it in the Discord server, and I can like sign you up. But yeah, you're gonna learn a lot about this in high school. So yeah, I don't think we have any more questions, right? Okay, yeah, I think we're done with this exercise. So from oops. Next we have like math contest questions, but like it's already been an hour, which is a little long, so I think I'll just schedule another class and like I can explain these math contest questions here. But for now, like if you guys want to like do these questions at home, you can. You have the link to the tutorial. I think I want you guys to at least take a look at these questions. Like you don't have to necessarily do them, but you should at least take a look at them just to see like what AMC 10 is like and like what type of questions there are. So yeah. And I also want you guys to look at these exercises here on our platform. We have a few exercises. I think we have like 10 here. So they're all like AMC questions. Um, you guys can try doing it if you want. It would be good for you, like just to give it a try. In the next class, I'll talk about these questions here.